So we have already discussed the inverse Z transform. Now from this class we will discuss on the transform analysis of LTI systems. So it is also part of inverse Z transform only, but here we do transform analysis. Transform means what? It is say uh, h of z is equal to y of z by x of z. That is the response of the LTI system we are going to analyze, and we are going to find out uh, either x of n or y of n or h of n using the transform analysis. That is uh, standard it is h of z is equal to y of z divided by x of z. That is response is equal to output by input. So that we are going to find out using the Z transforms here. Okay, so the very first problem, a causal system. I hope I'm audible to all. A causal system has input x of n and output y of n. Find the impulse response of the system if x of n is given by this equation and y of n is given by this equation. That is, we need to find out what is h of n if input to the system is this one, output is this one. So what we are trying to find out is, say you are applying x of n to an LTI system and you are getting an output y of n to the y of n as a output, and what is that h of n which is responsible for this y of n? We know that y of n is equal to convolution of x of n with h of n, correct? Already we have calculated these problems. We have already known to this that y of n is convolution of x of n with h of n. Okay, in time domain it is a tedious process. Now in frequency domain the same process is nothing but, give me a second, here y of z, if I convert it to the Z transform, that is discrete time signals Fourier representation is also in the form of Z transform, that if I represent, I will get y of z is equal to x of z multiplied by h of z. Now we have been given with y of n and x of n. So we can find out the Z transform of y of n and x of n. Then we can find h of z. That is, if I want h of z, what I should do? Y of z divided by x of z. Then we will get h of z. So taking inverse Z transform, I will get h of n. Sorry, it should be small h of n. Okay, that is what being asked here. Find the impulse response of the system. H of n we need to calculate. So this is the easier method. We need to first find out Z transform of y of n, x of n, then dividing y of z by x of z, we'll get h of z. After applying inverse Z transform, we'll get h of n. So this is the process in this analysis. Is that clear? So what is x of n? Let us solve this problem. X of n is equal to delta n, 1 by 4 delta n minus 1. X of, so let me write the LTI system transform analysis problems. Okay, this is transform analysis. In this the importance is for this equation. Y of n is equal to x of n convolution h of n. That means y of z is equal to x of z multiplied by h of z, and you want any of the value, that is say h of z you want, then you have to do y of z divided by x of z. Similarly, if you want x of z, then y of z by h of z. Okay, so these are the three equations we are going to use: 1, 2 and 3. Give me a second. So these are the equations we are going to use. Now x of n is, first problem is given as, given x of n is equal to delta of n plus 1 by 4 delta of n minus 1 minus 1 by 8 delta of n minus 2. This is our x of n. Okay. Next, y of n is given as delta of n minus 3 by 4 delta of n minus 1. We need to find out h of n. So we know now that we need to first find out what is y of z, then what is x of z, then take the ratio of both, we'll get h of z, then take the inverse z transform. So solution is, first we need to find out what is x of z. What is x of z? X of z is equal to, you know already that delta n's z transform is, say what I'm talking here is z transform of delta n plus 1 by 4 delta n minus 1 minus 1 by 8 delta n minus 2, z transform of this one. So z transform of delta n is 1 plus 1 by 4 z inverse minus 1 by 8 z to the power minus 2. This is x of z. Similarly, y of z is equal to z transform of delta of n minus 3 by 4 delta of n minus 1. So we know the z transform of delta n, which is 1 again here, 1 minus 3 by 4 z to the power minus 1. This is our y of z. So now what is h of z? Now h of z is equal to y of z divided by x of z. So y of z is 1 minus 3 by 4 z inverse divided by 1 plus 1 by 4 z inverse minus 1 by 8 z inverse square. Okay, this is h of z. Now before we find out h of n for this, what we have to do? We have to simplify it using partial fractions, correct? Since the number of zeros is less than number of poles, number of zeros, that is n is less than m. We have this condition, we can directly apply the partial fractions and write the h of z in the simplified manner. Some terms ಅಲ್ಲಿ ಬರಿಬಹುದು. It is combination of two terms, right? So we need to find out the two roots of z here. That is, we need to find out the roots of this one first. So let us do that. H of z is equal to, if you find out the roots, what you will get is, actually it is 1 by 2 and 1 by 4. Okay, the roots are plus 1 by 4 and minus 1 by 2. That's why we are going to get this as our next equation. This is, here it is minus 1 by 4, that means it is a plus 1 by 4. One root is 1 by 4, another one is minus 1 by 2. So what will get? 1 minus 3 by 4 z inverse divided by 1 minus 1 by 4 z inverse multiplied by 1 plus 1 by 2 z inverse. So this is the equation. Applying partial fractions, we can write it as 1 minus 1 by 4 z inverse plus a2 divided by 1 plus 1 by 2 z inverse. Now I hope all of you know how to find out a1 and a2 value. First we'll substitute z inverse is equal to, say, z inverse is equal to 1 by 4, right? Z inverse is equal to minus 4. Z inverse is equal to 4 if I substitute, that is correct. Z inverse is equal to 4, or z is equal to 1 by 4. And we'll get one value, that is a2. Similarly, z inverse equal to, this is 2, so that's why we can substitute minus 2, or z is equal to minus 1 by 2. Using that we'll get a1. So let me directly write these answers from here. So by substituting z is equal to minus 1 by 2, okay, we get a2, right? We'll get a2 and this is a1. So a2 will be 5 by 3 and a1 is minus 2 by 3. a2 5 by 3, a1 minus 2 by 3. Okay, I hope you are understanding. If you find anything like difficult, let me know at this stage itself. Okay, so a2 ಮತ್ತೆ a1 value find out ಮಾಡಿದ್ಮೇಲೆ what you will get is 1 minus 3 by 4 z inverse divided by 1 minus 1 by 4 z inverse into 1 plus 1 by 2 z inverse is equal to minus 2 by 3 divided by 1 minus 1 by 4 z inverse, sorry, plus 5 by 3 1 plus 1 by 2 z inverse. This is the answer we are going to get after solving for h of z using partial fractions. Now applying inverse z transform, we get h of n is equal to minus 2 by 3, and we know that this is in the form, say, 1 divided by 1 minus a, so which is nothing but a to the power n. So a is here 1 by 4. So it is 1 by 4 to the power n u of n. Okay, causal system ಅಂತ ಹೇಳಿದರೆ ಅದಕ್ಕೆ u of n ಅಂತ ಬರೀತಾ ಇರೋದು ಇಲ್ಲಿ. ನಾನ್ causal ಆದರೆ u of minus n minus 1 and we might have multiplied this also with minus. ಅಂದರೆ ಇವಾಗ ಪ್ಲಸ್ ಆಗಿರೋದು ಇದು. Plus 5 by 3. Here you can see a is plus here. That is, we are expecting 1 divided by 1 minus a, but here it is 1 plus a. That means it is 1 divided by 1 minus of a. Okay, that's why we need to write minus 1 by 2 to the power n u of n. So this is our transfer function h of n, or impulse response of the system with input given as x of n and output given as y of n. ಇದೆರಡು ಕೊಟ್ಟಿತ್ತು. From this we are able to find out what is the system's impulse response, okay, in the time domain. Is that clear? You can see this is the inverse the transform we will get. U of n is taken common at the end. Okay, you can do that. Here u of n and u of n, if you take common, it will be minus 2 by 3 1 by 4 to the power n plus 5 by 3 minus 1 by 2 to the power n u of n. Okay, I hope no doubt in this. Shall we move on to the next problem? So again, look at the question carefully. We want to design a causal system. Causal system means definitely n is greater than 0. It is a right-sided sequence. Whatever design we are doing, it is for the right-sided sequence. Here, input is x of n given, output y of n is also given. Determine the impulse response and the system function h of z. So impulse response ಅಂದಾಗ time domain ಅಲ್ಲಿ ಬರುತ್ತೆ, systems function ಅಂದಾಗ h of z. ಅಂದ್ರೆ we need to find out h of n as well as h of z. ಎರಡು ಆನ್ಸರ್ ಇವಾಗ. ಆವಾಗಲೇ ಇದ್ದ ಕ್ವಶನ್ ಅಲ್ಲಿ h of n the final answer was expected. Now h of z and h of n, both however we are going to calculate and we are going to write it. So second problem, 1 by 2n and 1 by 1 by, so the second problem is like x of n is equal to 1 by 2 to the power n u of n minus 1 by 4 into 1 by 2 to the power n minus 1 u of n minus 1. This is no need to panic if you get question like this. It is a time shifted version. Andre, if you are given with say x of n is equal to 1 by 2 to the power n u of n minus 1, it is x of n minus 1. This time shifted 1 by 2 n minus 1 u of n minus 1. Okay, ಈ ಟೈಮ್ ಶಿಫ್ಟೆಡ್ ವರ್ಷನ್ಗೆ z ಟ್ರಾನ್ಸ್ಫಾರ್ಮ್ ಏನಿರುತ್ತೆ, ವಾಟ್ ಎವರ್ z ಟ್ರಾನ್ಸ್ಫಾರ್ಮ್ you will get. Say for this one we get z transform as x of z, means for this one z transform will be z inverse into x of z. Using the properties we need to write the z transform of this signal. Here it is straightforward. The z transform will be say 1 by 2 to the power n means 1 divided by 1 minus 1 by 2 z inverse plus, sorry, minus we have here, so minus 1 by 4 z transform is 1 by 2, same again, but we get multiplication of z inverse. So let me solve this. Okay, so given is x of n as this one. First we'll concentrate on the given sequences, and y of n is 1 by 3 to the power n u of n. Y of n is 1 by 3 to the power n u of n. Okay, we have been asked to calculate h of n, that is impulse response of the system, h of z, that is transfer function. Okay, so the standard way to calculate both of them is, we know that y of n is equal to x of n convolution h of n, z transform of applying z transforms, we get y of z is equal to x of z multiplied by h of z. Okay, now what is h of z? First we'll have to calculate h of z, that is y of z by x of z. Okay, so for this we need to find out y of z and x of z, right? So after that, once we find h of z, then we can take z inverse to get h of n. First let us find out what is y of n, sorry, y of z, which is z transform for the 1 by 3 to the power n u of n. Z transform for this one is what? 1 divided by 1 minus 1 by 3 1 minus 1 by 3 z inverse. One by 3 z inverse. Similarly, for x of z, as I already told you, for the give me a second. Yes. For the given, we have 1 by 2 u of n, right? Is this correct? Yes. Z transform of 1 by 2 to the power n u of n minus 1 by 4 into 1 by 2 to the power n minus 1 u of n minus 1. Okay. For this, we need to find, means this term is 1 divided by 1 minus 1 by 2 z inverse, whereas next term is 1 by 4, this 1 by 4. Okay, multiplied by z inverse. Z inverse is because we are shifting the sequence by time n minus 1. Andre, instead of having 1 to the power 1 by 2 to the power n u of n, we are shifting it by minus 1. In the z transform, we are going to multiply the answer with z inverse. So ಅದಕ್ಕೆ z inverse ಅಂತ ಬರೆದಿರೋದು. divided by 1 minus 1 by 2 z inverse. Okay, this is our x of z. Now what is h of z? H of z is the ratio of h of z is the ratio of y of z and x of z. So this is 1 divided by 1 minus 1 by 3 z inverse divided by 1 divided by 1 minus 1 by 2 z inverse minus 1 by 4 z inverse divided by 1 minus 1 by 2 z inverse. Okay, this is our h of z. Now we need to simplify this. After simplification, this is what we will get: 1 minus 1 by 2 z inverse divided by 1 minus 1 by 3 z inverse into 1 minus 1 by 4 z inverse. Okay, this is the answer we are going to get after simplification. And so again the normal procedure continues here to finding out a1 and a2. Okay, I'm not going to solve that, just I wanted to bring it to this point. Same partial fractions we have already studied. So after simplification you will get this equation. You apply partial fractions as a1 divided by 1 minus 1 by 3 z inverse, a2 divided by 1 minus 1 by 4 z inverse. Okay, so you will get minus 2 and plus 3 as a1 and a2. Applying inverse Z transform, we will get minus 2 into 1 by 3 to the power n u of n and plus 3 1 by 4 n into u of n. So this term, this is our h of n. Okay, give me a second. So this is the answer. Is that clear? Now in the next problem, we have been given with a system has the impulse response h of n, which is equal to 1 by 2 to the power n u of n. Output as 1 by 3 u of n plus 2 by 3 minus 1 by 2 n u of n. So we have been given as, say, x of n system y of n. System impulse response is h of n. H of n and y of n is given. Now we have to find out x of n, that is input. Okay, so h of n ಕೊಟ್ಟಿದೆ, y of n ಕೊಟ್ಟಾಗಿದೆ. We need to find x of n. Again same equation we need to use. Let me consider y of n 1 by 3 and 2 by 3. Problem number 3, y of n is equal to 1 by 3 u of n plus 2 by 3 minus 1 by 2 to the power n u of n. Okay, and 1 by 2 as h. H of n is equal to 1 by 2 to the power n u of n. So for this system function and output, we need to find out what is x of n. We know that y of z is equal to x of z into h of z. So what is that we need to find out? We need to find out x of z, which is equal to y of z by h of z. And once we find x of z, we have to take inverse z transform to get what is the input. Okay, so let us follow the same procedure here. What is y of z then? Y of z is equal to 1 divided by 1 minus 1 by 3. No, not 1 by 3, sorry. It is not part of the equation. It is just a constant 1 by 3. So 1 by 3 divided by 1 minus z inverse. Because at this point a is equal to 1. 1 to the power n, which is not mentioned, correct? And plus 2 by 3, here it is minus 1 by 2. So a is equal to minus 1 by 2. That's why 1 divided by 1 minus a. This is the z inverse pattern, correct? So minus andre ಇಲ್ಲಿ ಏನಾಗುತ್ತೆ plus 1 by 2 z inverse ಅಂತ ಆಗುತ್ತೆ. That's why 1 divided by 1 plus 1 by 2 z inverse. This is our y of z. H of z is equal to 1 divided by 1 minus 1 by 2 z inverse. So here you can see the difference. 1 by 2 to the power n ಇದೆ, ಇಲ್ಲಿ minus 1 by 2 to the power n u of n ಇದೆ. So this is 1 divided by 1 minus 1 by 2 z inverse. This is 2 by 3, that is this constant, divided by 1 plus 1 by 2 z inverse. Now x of z is equal to, as we already found out, it is the y of z divided by h of z. So 1 by 3, 1 minus z inverse plus 2 by 3, 1 plus 1 by 2 z inverse, divided by 1 divided by 1 minus 1 by 2 z inverse. So this is x of z. Now simplifying this, that is we need to say cross multiply these two things, and then this will be like 1 divided by x divided by y. Using that form we need to simplify, and finally after simplification we will get this equation. So it is 1 minus 1 by 2 z inverse whole square, 1 minus 1 by 2 z inverse whole square, divided by 1 minus 1 by 2 z inverse minus 1 by 2 z inverse square. So this is the x of z we are going to get after simplification. Here you can see n is equal to m. N is number of zeros. Z inverse square andre 2 zeros, and z inverse 1 and 2. Here 2 poles. There are n is equal to m. Number of zeros ಮತ್ತೆ poles equal ಆಗಿರೋದ್ರಿಂದ, ಅಂದ್ರೆ zeros ಕಮ್ಮಿ ಇರಬೇಕು ಯಾವಾಗಲೂ ಪೋಲ್ಸ್ಗಿಂತ. ಇಲ್ಲಿ ಈಕ್ವಲ್ ಆಗಿದೆ ಅಥವಾ ಜಾಸ್ತಿ ಇದೆ ಅಂತ ಅನ್ಕೋಬಹುದು. ಈಕ್ವಲ್ ಅಥವಾ ಜಾಸ್ತಿ ಇದೆ ಅಂತ ಅಂದ್ರೆ then partial fractions cannot be applied directly. So you use the long division method. First 1 minus 1 by 2 z inverse whole square. This we need to expand. After expanding we need to apply the long division method. So after expanding we'll get this as our equation. Okay, so this is our equation. After expanding, here we know that there are two poles, two zeros and two poles, and hence cannot apply the partial fractions directly. We have to use the long division methods, long division method, so as to get this sequence. Okay, after applying the long division method, which I taught in the previous class, we will get minus 1 by 2. That is, only once we have to apply. Only once we have to apply. Then we will get minus 1 by 2, which is on the top. Minus 1 by 2 ಅಂತ ಬರುತ್ತೆ ಇಲ್ಲಿ. ಉಳಿದಿದ್ದ equation ಇಲ್ಲಿರುತ್ತೆ. So minus 1 by 2 minus 5 by 4 z inverse plus 3 by 2. Minus 5 by 4 z inverse plus 3 by 2 divided by the same term, that is 1 minus 1 by 2 z inverse minus 1 by 2 z inverse whole square. This is very important problem, remember it, because not every problem is having n equal to m. Always we refer n less than m, ಅಥವಾ zeros are lesser than number of poles. ಅವಾಗ ಡೈರೆಕ್ಟ್ ಆಗಿ ಪಾರ್ಷಿಯಲ್ ಫ್ರಾಕ್ಷನ್ ಅಪ್ಲೈ ಮಾಡಬಹುದು. ಇದಕ್ಕೆ ಸಾಧ್ಯ ಇಲ್ಲ. ಸೊ ಅದಕ್ಕೆ ಲಾಂಗ್ ಡಿವಿಷನ್ ಮೆಥಡ್ ಯೂಸ್ ಮಾಡಿ ಫಸ್ಟ್ ಟರ್ಮ್ ಒಂದನ್ನ ರಿಮೂವ್ ಮಾಡ್ತಾ ಇದೀವಿ. z ಇನ್ವರ್ಸ್ ಸ್ಕ್ವೇರ್ ಇತ್ತಲ್ವಾ, ಈಗ z ಇನ್ವರ್ಸ್ ಬಂದಿದೆ. ಸೊ ನಾವು ಯು ಕ್ಯಾನ್ ಅಪ್ಲೈ ದ ಪಾರ್ಷಿಯಲ್ ಫ್ರಾಕ್ಷನ್ಸ್. ಫಾರ್ ದ್ಯಾಟ್ ಫಸ್ಟ್ ಯು ಹ್ಯಾವ್ ಟು ಫ್ರಾಕ್ಷನೈಸ್ ದಿಸ್ ಒನ್, ಅಂದ್ರೆ z ರೂಟ್ಸ್ ನ ಫೈಂಡ್ ಔಟ್ ಮಾಡಬೇಕು. ಸೊ ಡೈರೆಕ್ಟ್ಲಿ ಯು ಕ್ಯಾನ್ ಫೀಡ್ ದಿಸ್ ಇನ್ ಟು ಕ್ಯಾಲ್ಕುಲೇಟರ್ and find out the roots. Then the roots will be, say this equation will get transformed into minus 5 by 4 z inverse plus 3 by 2 divided by 2 terms we will get. So what are these two terms? One is root is 1 minus z inverse, another root is minus 1 by 2, that's why 1 plus 1 by 2 z inverse. Okay, 1 minus z inverse, 1 plus 1 by 2 z inverse. So now you can apply the partial fractions for this one. This one we can consider as x1 of z. So x1 of z is equal to a1 divided by 1 minus z inverse plus a2 divided by 1 plus 1 by 2 z inverse. By this method we will find out a1 and a2 to be 1 by 6 and 4 by 3. So 1 by 6 divided by 1 minus z inverse plus 4 by 3, 1 plus 1 by 2 z inverse. This is x1 of z. Okay, minus 1 by 2 was there in x of z. Final answer would be x of z is equal to minus 1 by 2 plus 1 by 6, 1 minus 1 by plus 1 by 6 by 1 minus z inverse plus 4 by 3 into 4 by 3 divided by 1 plus 1 by 2 z inverse. So this is x of z. ನಮಗೆ ಇನ್ಪುಟ್ z ಟ್ರಾನ್ಸ್ಫಾರ್ಮ್ ಫಾರ್ಮ್ ಅಲ್ಲಿ ಇದೆ. Now applying inverse z transform, we will get x of n is equal to minus 1 by 2. 1 by 1 ಅಂತ ಇದ್ರೇನೆ ಸಾಕು delta n ಅದು. So minus 1 by 2 is the amplitude of delta n, minus 1 by 2 into delta n. This is the inverse z transform of minus 1 by 2. Okay, this second term plus 1 by 6, ಇಲ್ಲಿ z inverse ಹಿಂದ್ಗಡೆ 1 ಇದೆ, ಅಂದ್ರೆ 1 to the power n u of n plus 4 by 3, this term 4 by 3 divided by 1 plus 1 by 2, that's why we will write minus 1 by 2 to the power n u of n. So this is our x of n. ಇದು ನಮ್ಮ ಇನ್ಪುಟ್. ಬೇರೆಲ್ಲ ಪ್ರಾಬ್ಲಮ್ ಅಲ್ಲಿ ಇನ್ಪುಟ್ ಮತ್ತೆ ಔಟ್ಪುಟ್ ಕೊಟ್ಟು h of n ಫೈಂಡ್ ಔಟ್ ಮಾಡಕ್ಕೆ ಹೇಳಿದ್ರು. ಈ ಪ್ರಾಬ್ಲಮ್ ಅಲ್ಲಿ output and output and h of n was given, x of n was the required thing, so we have found it out. Is that clear? So this is the answer we have got. Correct. Now last problem for today, that is an easier problem here. Given is y of n minus 1 by 2 y of n minus 1 equal to 2 into x of n minus 1. So it is a very easy problem. We are going to find out say h of n using the given equation. Given equation is y of n minus 1 by 2 y of n minus 1 equal to 2 into x of n minus 1. So look at this problem. Here output, delayed version of output and input. So it is a relation between output and input is given. We need to find the system function h of n. So this is the system which produces this y of n based on its input x of n. So z transform of x of n will give us x of z. Z transform of y of n will give us y of z. And what about z transform of x of n minus 1? It will give us z to the power minus 1 into x of z. Similarly, y of n minus 1 is there, means z transform of this would be z inverse into y of z. Okay, this is a time shifting property. Using these above terms, we can write the equation as y of z minus 1 by 2 z inverse into y of z, that is first term y of z, second term minus 1 by 2 into z inverse y of z equal to 2 into say this one, right, x of n minus 1, z inverse into x of z, z inverse into x of z. Okay, so now I have to take y of z as common. Y of z, if I take common, it would be, sorry, y of z is common, 1 minus 1 by 2 z inverse, and this is 2 z inverse x of z. Now it is I will take y of z divided by x of z, which is equal to 2z inverse divided by 1 minus 1 by 2z inverse. So ಇವಾಗ ಏನಾಯ್ತು, ನಾನು ರೇಷಿಯೋ ತಗೊಂಡಿರೋದು x of z I have moved on this side, and 1 minus 1 by 2z inverse I have moved on the right hand side. So with that, what we have got? We have got a ratio. What is this ratio? This ratio is nothing but h of z, y of z by x of z andre output by input andre transfer function of the system. So h of z is equal to 2 into z inverse divided by 1 minus 1 by 2 z inverse. Okay, so now if we find for this transfer function what is inverse z transform, what is inverse z transform of this one? Correct, applying inverse z transform we will get h of n. Correct alva? So what is that? We need to write it separately. 2 into z inverse multiplied by 1 divided by 1 minus 2 z inverse. Directly illeno partial fractions ಏನು ಬೇಕಾಗಿಲ್ಲ, just you have to apply your knowledge on the z transform and its properties. So ಏನಿದೆ ಇದಕ್ಕೆ z transform ಏನು ಬರುತ್ತೆ, 1 by 2 to the power n u of n, but it is multiplied by z inverse. ಓಕೆ, 2 ಅಂದರೆ ಕಾನ್ಸ್ಟೆಂಟು, ಹಾಗೆ ಇಡ್ಬೋದು. ಮಲ್ಟಿಪ್ಲೈಡ್ ಬೈ z ಇನ್ವರ್ಸ್ ಇರೋದ್ರಿಂದ z ಟ್ರಾನ್ಸ್ಫಾರ್ಮ್ ತಗೊಂಡಾಗ n will become n minus 1 and this will be u of n minus 1. Okay, this is the answer. So h of n is equal to 2 into 1 by 2 to the power n minus 1 u of n minus 1. This is our system's impulse response for the given input output relation. ಇಲ್ಲಿ input output relation ಏನಂತ ಕೊಟ್ಟಿದ್ರು, ಇದು. This is the input output relation. For this we have found out what is h of n using z transform and inverse z transforms. Is that clear? Let me know if you have any doubts. Let me know if you have any doubts. Darshan, are you there? Rashmi? Was I audible throughout? Manjesh?
Yes, sir.
Audible ಇತ್ತಲ್ವ ಎಷ್ಟೊತ್ತು?
ಇತ್ತು sir.
Okay. So any doubt regarding this? I am going to upload this. Those who did not attend or any confusion, you can contact me anytime regarding this, because ಇದರಲ್ಲಿ ಒಂದು ಪ್ರಾಬ್ಲಮ್ ಬಂದೇ ಬರುತ್ತೆ ಡೆಫಿನೆಟ್ಲಿ. ಇನ್ವರ್ಸ್ ಝೆಡ್ ಟ್ರಾನ್ಸ್ಫಾರ್ಮ್ ಆದಮೇಲೆ ಟ್ರಾನ್ಸ್ಫಾರ್ಮ್ ಅನಾಲಿಸಿಸ್, ಈ 4 ಪ್ರಾಬ್ಲಮ್ ಇದೆ ಅಲ್ವಾ, ಇದರಲ್ಲಿ ಒಂದು ಪ್ರಾಬ್ಲಮ್ ಬರುತ್ತೆ. ಇನ್ನೊಂದು ನೆಕ್ಸ್ಟ್ 2 ಕ್ಲಾಸಲ್ಲಿ ಸಾಲ್ವ್ ಮಾಡ್ತೀನಿ. ಅದಾದಮೇಲೆ ನೆಕ್ಸ್ಟ್ ಒಂದು ಕ್ಲಾಸಲ್ಲಿ ಇನ್ವರ್ಸ್ ಝೆಡ್ ಟ್ರಾನ್ಸ್ಫಾರ್ಮ್ ಕಂಪ್ಲೀಟ್ಲಿ ರಿವೈಸ್ ಮಾಡ್ತೀನಿ, ಅಂದರೆ ನಾಳೆ ಮತ್ತು ನಾಡಿದ್ದು. ಸೊ ಇದರಲ್ಲಿ ಯು ವಿಲ್ ಗೆಟ್ ಆ್ಯಕ್ಚುಲಿ 15 ಮಾರ್ಕ್ಸ್. ನೀವು ಇನ್ವರ್ಸ್ ಝೆಡ್ ಟ್ರಾನ್ಸ್ಫಾರ್ಮಲ್ಲಿ ಒಂದು ಕ್ವಶನ್ ಎಕ್ಸ್ಪೆಕ್ಟ್ ಮಾಡ್ಬೋದಾದರೆ, ಈ ಟ್ರಾನ್ಸ್ಫಾರ್ಮ್ ಅನಾಲಿಸಿಸ್ ಇವತ್ತು 4 ಪ್ರಾಬ್ಲಮ್ ಸಾಲ್ವ್ ಮಾಡಿದ್ರಲ್ಲಿ ಒಂದಾದ್ರೂ ಈ ರೀತಿ ಇರುತ್ತೆ, ಇನ್ನೊಂದು ವಿತ್ ಇನಿಷಿಯಲ್ ಕಂಡೀಷನ್ಸ್ ಬರುತ್ತೆ, ಯುನಿಲ್ಯಾಟ್ರಲ್ ಝೆಡ್ ಟ್ರಾನ್ಸ್ಫಾರ್ಮ್ಸ್ ಅಂತ ಬರುತ್ತೆ. ದಟ್ ವಿಲ್ ಸಾಲ್ವ್ ಟುಮಾರೋ ಆ್ಯಂಡ್ ದಟ್ ವಿಲ್ ಕಂಪ್ಲೀಟ್ ಅವರ್ ಸಿಲೆಬಸ್ ಫಾರ್ ಝೆಡ್ ಟ್ರಾನ್ಸ್ಫಾರ್ಮ್. ಅದಕ್ಕೆ ಡೂ ಅಟೆಂಡ್ ದ ಕ್ಲಾಸ್ ಟುಮಾರೋ ಆ್ಯಂಡ್ ಡೇ ಆಫ್ಟರ್ ಟುಮಾರೋ, ಸೊ ದಟ್ ವಿಲ್ ಫಿನಿಶ್ ಆಫ್ ಆಲ್ ದ things. Okay, is that clear? So thank you for joining. I have taken the attendance directly from this.